Okay, so let's look at how we can determine the acceleration vector in, like, we are given that expression, but we are told that we don't need to find our unit tangent vector as well as the principal normal vector. So before we even continue, it's very important that we understand um, what each and every term mean in this equation that we have there. Okay, and I guess before we continue, just in case you are new to the channel, we upload engineering content that includes mathematics as well. Um, so to ensure you're not you don't miss out on any content that we upload, uh, make sure to subscribe, ring the notification bell so that each time we upload new content, you'll be notified. Okay, so in this case, we're going to say our A is the acceleration in this case. Then our AT, meaning I don't really want to call it A sub t, but let me just call it AT. That's our tangent magnitude. Tangent magnitude. So you may hear that sometimes the tangent magnitude, they call it the uh, scalar multiple. Okay, scalar multiple of the tangent unit tangent vector. Scalar multiple over t. Okay, then we have our t itself, which is our unit tangent vector. Okay, then our an is our normal magnitude. Normal magnitude there, and you may find that sometimes this is called the scalar multiple of the normal magnitude itself, the principal normal magnitude. Then our n itself is the principal, um, it's a normal magnitude, principal normal magnitude. Is it magnitude? No, vector rather. That's the principal normal vector. Okay, so that is what all these terms mean in that expression that we're given. That's what they stand for. So our first of all, like, we don't really have to determine our tangent vector as well as the principal normal vector. We just have to determine what our AT is. Okay, and in this case, we can determine this by saying it's a d dt dt over um, that's the magnitude of r prime of t, which is equals to d dt of the magnitude of v. You can also write it in this way or that way, still one and the same thing, because our v is nothing but r prime of what? R prime of t. Okay, so the thing is that before I go to my an, which is my normal magnitude, you can also determine your AT in a different way, and this cause that we remind ourselves of the speed vector. So let's say if it's in the form ds dt, that will be equals to the magnitude of r prime of what? R prime of t, which is sometimes written as the square root of, or perhaps which is equivalent to the square root of dx dt squared plus dy dt squared plus dz dt squared, like that. So it's one and the same thing. So to determine what our AT is, our AT will be equals to d2s dt2. Okay, so you can, I'm going to use this method, but you can try to apply this one uh, just to try to confirm. Okay, at your own free time. So what about our an? Our an is simply equals to the square root of the magnitude of a squared plus, no, no, not plus, but minus, mm, minus my at squared, like that. Okay, so another way that I can use to determine my a of n, a of n, which is my normal magnitude, would be my k uh, multiplied by ds dt squared, like that. But this will take a lot of time. Why? Because we have to find our k. Our k is the curvature there, and for us to find the curvature, meaning we have to find what our t is there, and taking that route isn't really a good idea in this case unless otherwise. So I'll just simply use these two. They'll really help me to come up with my AT as well as my AN. And I have to remind myself of what my AN is. My A is equals to R prime of t, meaning the second derivative of our vector. So let's say we have our vector. Let's say we have our vector equals to let's say our vector is equals to something like we say RT equals to something like t plus 1 in the I plus 2t in the j plus t squared in the k, and we are told to find where t is equals to what? T is equals to 1. So the derivative of that r prime of t will be equals to, that will be I plus 2j plus 2t in the k, like that. Okay, so we have to determine the magnitude of that. So you're going to say d dt of the magnitude of r prime of t. We're talking about the square root of, that's a 1 squared plus 2 squared plus open bracket, I'll say 2t squared, of which this is simply d dt. What you're finding here is our 18 d dt of I'll say 1 squared is 1, then 2 squared is 4, so 4 plus 1, that gives us a 5 plus 2 squared is a 4, t squared to the power 1 over 2. So to differentiate that, the power is going to drop. You're going to have 1 over 2. Okay, then differentiate what you have inside. In fact, we're using chain rule here. The derivative of what you have inside is 8t. Then we are going to have your 5. You're going to have your 5 here plus 4t squared. The power is going to drop. You're going to like 1 over 2 minus 1. That will give us minus 1 over 2. So of which our 8t will be equals to 2 into 2 1, 2 into 8 is 4. That would be like 4t divided by the square root of 5 plus 4t squared. But we are told that we are evaluating at t is equals to 1. So this is going to become 4 divided by 4. That would be t squared, more like 1 squared. That would be a 1 by 4. That's a 4. 4 plus 5, that's a 9. So root of 9 is a what? Is a 3. So that's what our AT is there. So I found that our AT, our tangent magnitude, is equals to 4 over 3. Okay, so even if you use the other method, it's still going to be one and the same thing. So let's try to determine our normal magnitude. So our normal magnitude in this case, AN will be equals to. So now my A is the second derivative of that. Okay, so before I even do that, I'll say my A is equals to the second derivative of that is simply a 2. Then if I say my magnitude of A as it is written here is simply equals to, we are saying that's a 2 squared, like that. So this square and that square goes, that is equals to 2. So when you bring it and say AN will be equals to the square root of this, because the square root of that would be a 4 minus, then our 8t we found 4 over 3, then we say squared. That gives us the square root of 4 minus 16 divided by 3. So this turns out to be no, not by 3 but by 9 rather. So this will be a 9. So that turns out to be, we're saying 4 multiplied by 9, that gives us 36 minus 16 divided by 9, giving us root of 20 divided by root of 9. So simplifying that, on the numerator it's more like I have root of 4 multiplied by root of 5 divided by, of course we have a 3. So root of 4 is 2, so that would be 2 root 5 over what? Over 3. And that's our A of n. So our AN is simply equals to 2 root 5 over what? Over 3. So we can now write the expression that we needed. this will be equals to, our acceleration will be equals to our at. We found that it's 4 over 3 t, that's plus an. We have found 2 root 5 over 3, then we have our n there, and this is the expression that we are looking for. Okay, so let's try to look at another example. Perhaps this will even make more sense. So let's say we have our rt equals to, let's say it's t squared here, I plus, that's t plus t to the power 3 over 3 in the j, plus, that's t minus t to the third over 3 in the k, and we are taught to evaluate at t is equals to 0. Okay, so I'll find my r prime. R prime of t is simply equals to 2t in the I plus 1 plus, that will give me t squared in the j, because we are going to drop the power, and the 3 of course is a power. You're going to cancel out with the 3 we have on the denominator here, then reduces by 1, that will be a 2, then plus, that will be a 1 minus t squared in the k. So to find my at, we're just finding the, it's more like the, we say the dt, which is the magnitude of what we have here. So the magnitude that I have there, that will give me 4t squared. Let me write it in a bit of like in an orderly manner, writing step by step. So that would be like, we are saying our 2t squared plus, we have 1 plus t squared plus 1 minus t squared like that. So this turns out to be d dt. Going to have the, what are we going to have? So we're going to have this, the square root of, that will give us 4t squared plus 1. Expanding that, we're going to have 2t squared plus t to the fourth, then plus 1 minus 2t to the second plus t to the fourth. Okay, so we observe to say this and that can go. So what remain with is our d dt, the square root of. So what we have is a 4t squared plus a 2, which is a result of 1 plus 1. Then we have plus what? Plus t to the fourth. So what I'd want you to keep in mind here is that, remember to say we are evaluating at t is equals to 0. So if I substitute here t is equals to 0, it's okay. So it's more like the method that I've taken is like more like a longer method. So you can even choose, just at this point you substitute in advance. Okay, so even at this case, at this point, I can substitute a t here and a t there. That would be like a 0 by 4. That's a 0. 0 to the power 4 is still 0. So meaning I'm looking for d dt of the square root of what? Square root of 2, which is simply what? Is 0, because you're differentiating a constant. So I found that my at is equals to 0. So what about my an? My an is equals to the square root of magnitude of a squared minus at squared, like that. So our a is simply the second derivative of what we have there, which is differentiating this, what we get is a 2. Then differentiating this part, what we get is plus, in fact that would be in the I, we are going to get 2t in the j, then minus 2t in the k. Okay, that's the second derivative. And you observe to say, even at this point, I think I can substitute in advance. This will give me a 0, and that will give me a 0. Okay, so the magnitude of that will be equals to the square root of 2 squared, that goes and that goes, you remain with a 2. So when you put a square there, that will be like a 4 minus, what do I get here? This is a 0 squared. That will give me what? It will give me a 2. Okay, it will give me a 2 there. So it basically means the expression that I'm looking for is my a is equals to my a_t I found is 0t, like that, plus my an I found 2 multiplied by n there, and this is the expression of the acceleration that we are looking for. And that's simply how you go about answering that question. Thank you very much for watching.